Getting BigQuery data into Excel is usually quite a manual grind, and it's especially frustrating if you're doing it multiple times a day. Logging in, navigating, exporting, formatting, copying, it's a real drag. However, in this video I'll show you how to do it all from Excel, and with just one click. We'll cover pulling and pushing data, no external libraries or complex setups needed. Let's dive in. First, we need a table in BigQuery to hold our data. Therefore, go to the Google Cloud Console and open BigQuery. Find your project ID, click the three dots and choose Create Dataset. Let's name it Demo and click Create Dataset. Now select the demo dataset and click Create Table. We'll name our table Data. For this example, we'll keep the schema very simple. Add a field named ID with type string and add a field named Name also with type string. Finally, click Create Table. We can also add some sample data directly in BigQuery using SQL. Now that we have our table set up in BigQuery, we need to configure Excel to communicate with it. We'll rename the first sheet to Data. This is where our sync data will reside. Then create a second sheet named Controls. We'll use this sheet for inputs and buttons to manage the sync process. To start coding in VBA, we need the Developer tab. If you don't see it, go to the Excel settings for ribbon and toolbar. On the right side under Main tabs, find Developer and make sure the checkbox next to it is checked. In the VBA editor, go to Insert and select Module. You can rename the module to something like BQ-Sync. Before we start coding the BigQuery sync, let's quickly go over some VBA basics. In VBA, we have sub-procedures that perform actions and functions that return values. We declare variables using dim and use the method worksheets to access specific sheets. Lastly, the value method gets or sets cell values. This hello world sub shows a simple interaction. We declare a worksheet object named WS, a string variable named username, and a string variable named greeting. We set the variable WS to our data sheet and read a user's name from cell A1. If A1 is empty, greeting becomes hello world. Otherwise, it personalizes the greeting to hello username. The code then writes the greeting to cell B1, makes it bold, and sets the font color to green. Finally, it displays a message box. The text is generated by calling the format greeting function. Let's test our hello world sub to see it in action. First, I'll type Jim to cell A1 of our datasheet. Now I'll go back to the VBA editor, make sure my cursor is within the hello world sub and click the run button. As you can see, we get a message box that says hello Jim. Also, cell B1 now displays hello Jim formatted in bold green text. Now that we have our Excel environment set up and a basic understanding of VBA, let's check how we can fetch data from BigQuery. There are 4 ways of doing this. 1. The web UI, the simplest way. Just go to BigQuery in the Google Cloud Console, type your SQL query and hit run. Great for quick checks, but not exactly scriptable from Excel. 2. The BigQuery command line tool. This is powerful, but it requires installing the Google Cloud SDK. That's a deal breaker for us. We want our Excel solution to be portable. You should be able to send the file to a colleague without them having to install extra software. 3. Client libraries. These are language-specific libraries that simplify BigQuery integration. You will find them for Python, Java, and other popular languages. Unfortunately, there's no official client library for VBA. And then there is the API. This is the most direct way to interact with BigQuery programmatically. You send HTTP requests directly to BigQuery's API endpoints. This is the perfect solution for VBA because we can make HTTP requests natively within Excel without relying on external dependencies. This keeps our solution self-contained and easily shareable. But here's the catch. If we just send a query to the API, BigQuery will reject it. We need to prove to BigQuery that we are authorized. We need an access token. The BigQuery web interface, the BQ command line tool, and the client libraries handle this authorization process behind the scenes. But since we are using the API directly from VBA, we have to handle it ourselves. One option would be to create a service account, download its key file, and then manually construct and sign a JSON Web Token in VBA. That's quite complicated. So here's a simpler approach. We'll offload the token generation to a cloud function. This function will use Python client libraries to obtain an access token using our service account key file. All our VBA code then needs to do is send the service account key file content to our cloud function, and it will return a fresh access token. We can then use this token to make authorized calls to the BigQuery API. Let's head over to the Google Cloud Console to set this up. First, navigate to IAM and Admin, and then Service Accounts. Click Create Service Account. Give it a descriptive name like Excel Sync SA and grant it the roles BigQuery Data Editor and BigQuery Job User. Now we need the service account's credentials. Select the newly created service account. Select Manage Keys, then Add Key and Create New Key. Select JSON as the key type and click Create. This will download a JSON file containing the service account's private key. Finally, let's store the key file in Excel. Open your Excel workbook and go to the controls sheet we created earlier. Open the JSON key file you just downloaded in a text editor, copy the entire contents of the file and paste it into a cell of your controls sheet. Now that we have our service account set up and its keys stored in Excel, we can create our cloud function. Here is a sneak peek at the code. The function retrieves JSON data sent from Excel containing the service account information. It checks if the required information is present and returns an error if not. If valid, it uses the method fromServiceAccountInfo to create credentials based on the provided service account info. The function generates a token using the refresh method and extracts it from the credentials token attribute. Finally, it returns the access token in a JSON response. Now that we understand the code, let's get this cloud function deployed. In the Google Cloud Console, go to Cloud Functions. Click Create Function, give your function a name like Token Generator, and crucially under Authentication, select Allow unauthenticated invocations. This is essential so our Excel can call the function without needing its own authentication. Paste the Python code we just reviewed into the code editor, create a file named requirements.txt and add the required packages. Lastly, click Deploy. With that, let's switch gears to Excel and write the VBA code that will use this cloud function to get our access token. This VBA code fetches BigQuery data and writes it to Excel. There's a main subroutine called execute BigQuery and populate sheet that orchestrates the entire process, calling on several supporting functions to handle specific tasks. Let's start by looking at the main function and then we'll check out the details of each of these supporting functions. Execute BigQuery and populate sheet does the following. First, it gets the necessary information from the controls sheet, that is, the service account information and the SQL query we want to run. Then it calls the getAccessToken function to retrieve an access token. Next, it uses the query-BigQuery function to actually send the query to BigQuery using the access token. Once it receives the result from BigQuery, it calls the addQueryResultToDataSet function to format the data and put it into the datasheet. Finally, it displays a message confirming that the data download is complete. Now that we understand the overall flow, let's take a closer look at the supporting functions that execute BigQuery and populate sheet uses. These functions handle specific parts of the process, such as parsing data, making HTTP requests, and handling authentication. We'll go through them in the order they are called by the main function. Before we can use the service account information, we need to clean it up a bit. The parseServiceAccountInfo function takes the raw service account information from the controls sheet and makes sure it's in correct JSON format. This involves trimming extra spaces and handling new line characters. The getAccessToken function takes the parseService account information and sends it to our cloud function. The cloud function then returns an access token which is extracted and parsed. With the access token in hand, the query-BigQuery function builds the request to the BigQuery API. It constructs the API URL and the request body containing our SQL query. It then uses the HTTP request function to send the request to BigQuery. This function returns the raw JSON response from BigQuery. The HTTP request function is a general purpose function for making HTTP requests. It takes the URL, request body and optionally an access token as input. It uses curl to send the request and handles the response. This function is crucial for communicating with both Cloud Function and the BigQuery API. Finally, the addQueryResultToDataSet function takes the raw JSON response from BigQuery and parses it. It then neatly formats the data and writes it to the datasheet. Let's demonstrate the data retrieval process. First, we need to ensure the necessary configuration is in place by checking the controls sheet. We can see that we have everything required to make the call to BigQuery. Now let's check out the datasheet. As you can see, it's currently empty. This sheet will be populated with the results of our BigQuery query. With the configuration verified, we can now execute the VBA code responsible for fetching the data. This triggers the series of functions we discussed earlier, including the token generation, query execution, and data parsing. As you can see from the pop-up message, and from the populated datasheet, the data has been successfully imported. Just as we can retrieve data from BigQuery, we can also send data from Excel to BigQuery. The structure of this code is similar to the download functionality, using a main orchestrating subroutine and several supporting functions. Here, the main subroutine is called upload data to BigQuery. It retrieves the necessary information from the controls sheet and then acquires an access token using the getAccessToken function, just as we did when pulling the data from BigQuery. Calling the prepare and upload data function is where this deviates from the data pull process most. Finally, it displays a confirmation message. Most of the work is done within the prepare and upload data function. This function handles the following. It takes the access token, project ID, dataset name, table name, and datasheet as input. It determines the data range in the datasheet and checks for the presence of headers. It extracts the headers and data from the sheet and constructs the JSON request body. This body contains an array of JSON objects where each object represents a row of data from the Excel sheet. This formatting is required by the BigQuery insert all endpoint. Finally, it sends a single HTTP post request to the endpoint using the HTTP request function, including the access token for authorization. Let's go ahead and try out the upload functionality. First, we need to prepare prepare some data for the upload. Since we just downloaded some data, let's clear the sheet to avoid confusion. In the data sheet, enter some new data. Now let's trigger the upload process to send this new data to BigQuery. We can see a message box indicating that the upload was successful. To verify, let's clear the datasheet again and trigger the download process one more time. If we check out the datasheet again, we see 2 rows of data. The original data retrieved from BigQuery and the new row we just uploaded. Finally, let's make the sync process more user-friendly by adding buttons to our controls sheet. This way, you won't have to go into the VBA editor every time you want to sync data. We will create 2 buttons, one for the download and one for the upload. We will use the add styled buttons subroutine to do the following. Firstly, set up the worksheet. Then, delete existing buttons. Third, create the download button. And lastly, create the upload button. Now that the buttons are in place, syncing the data is incredibly simple. Let's upload the currently present data 3 times, then click download and revisit the data page. As you can see, the data from our recent uploads now populates the sheet alongside the originally downloaded data. And that's it. Thank you for watching. If you want to use this in your own work, the description has all the details.